Aloha everybody, this is Gigi from Kauai Community College. In this video, we are studying the end behavior of the function. In this case, the function f of x is x squared, 6x squared plus 1 over square root of 9x to the fourth power plus 3x plus 1. Now the end behavior means what happened way out there. That means what happened to this function as as x is approaching infinity, and then what happened as x is approaching negative infinity. So we're talking about what happened to this function way out there to the right and way out there to the left. So 6x squared plus 1 over square root of 9x to the fourth plus 3x plus 1. So the end behavior, or study the horizontal asymptote, or is it a slant asymptote? These are the same concept, and it is the concept of limit at infinity. So you are looking at limit as x goes to infinity or x goes to negative infinity of your function. So this would be x6 x squared plus 1 over square root of 9x to the fourth plus 3x plus 1. Now, when studying this here, one of the things that we must pay attention to, which happened in your algebra class, is this. What is square root of x squared? Well, we would think square root of x squared will undo each other and it will just give you x. But the answer really is not just x, but the absolute value of it. Because we know that a square root function goes like this. And for it to be a function, we are only taking the positive answer, right? So square root of some number is a positive number. So that is what we are saying here. That's why we put the absolute value on there. Okay, and then the absolute value of x in turn is the absolute value of x is either itself or its opposite. Itself if it was a positive number, and then its opposite if it is a negative number. So in other words, when we are dividing by, in this case, we want to divide by x squared to both the top and the bottom, right? On the top, we'll divide by x squared, but on the bottom, we really are dividing by not x squared, but the square root of x to the fourth. Now, is that correct, what I just wrote? And that would be, the answer to that would be no, because we know we really have to, yes and no, I guess. We really have to pay attention to what is square root of x to the fourth, right? Square root of some number has to be a positive number. So is this a positive value? And the answer is yes. So that is an okay thing to say, right? But if you had divide by this, x to the 6 on the denominator, square root of x to the 6 on the denominator, then on the numerator, we better have absolute value of x to the third, because x to the third could be a negative number. Okay, and we'll go ahead and do that in just a second. But for now, we would say because x squared is a positive number, so then square root of x to the fourth is equal to x squared, and that is okay. So then we would say that is equal to limit as x goes to infinity of 6 plus 1 over x squared. And then here we have square root of 9 plus 3 over x to the third plus 1 over x to the 4th. These will go to 0 as x goes to infinity. So you really have 6 divided by square root of 9, which is 3. 6 divided by 3 is 2. So the limit as x goes to infinity of f of x is 2. And that is the end behavior of the function to the right. Okay, in other words, we would say that there is a horizontal asymptote at y equals 2. Okay, now what happened when we are approaching negative infinity? Will this still hold? Will the value of that still hold? Okay, so we would still be doing the same. X squared on the numerator divided by square root of x to the 4th. Now, when x is a negative number, it really doesn't matter because what you are doing here is you are going to raise that to the 4th power. So it becomes positive, and then square root is x squared, which is a positive number. So that is still an okay thing, and you still obtain the same answer as above. Okay, so that is the horizontal asymptote, and it goes straight across both to the left and to the right. So you would say then, limit as x goes to negative infinity is the same as the limit of x goes to positive infinity, and that is 2. So you have one horizontal asymptote at x equal to 2. Okay, now I alluded to the problem when that instead of x to the 4th power, say you have something different, say x to the 6th, for example. Okay, so I'm going to leave myself, give myself some room here, and I'm going to make up a problem to talk about that issue. Okay, so here is a problem that we will consider. So suppose we were looking at limit as x goes to infinity of, say, x to the 3rd minus 3x squared plus 5 divided by square root of 2x, how about 4, because I want to make that nice, 4x to the 6 minus 4. Okay, so there's that. Now, if we were to go and divide the numerator by x to the 3rd, the denominator we will have to divide by square root of x to the 6, because x to the 6 is relating to x to the 3rd, right? Now, that seems to be an okay thing to do. However, the square root, remember, of x squared is not x, but absolute value of x, because the square root something has to be a positive number. And then here you would get itself or its opposite. So, so then you would really do have to pay attention to excuse me on that, for that coughing there. Sorry about that. So this right here would be positive or negative depending on whether x is a positive number or a negative number, right? Because the opposite of a negative number is a positive number. So when you're looking at this problem right here, square root of x to the 6, when you divide by square root of x to the 6 on the denominator, on the numerator, we should write absolute value of x to the 3rd, because x to the 3rd could be a negative number and the square root of something must be positive. Okay, so how does that change? Well, when x is a positive number, it really doesn't matter, but it will make a difference when x is a negative number. So when limit as x goes to infinity, right here you have x to the 3rd over, and then you would now consider the fact that x is a positive number. How do we know that x is a positive number? Well, because x is approaching infinity. In positive infinity, it's a positive big number. So right here, absolute value of x to the third would be itself, which is x to the third. So then you will have that minus 3x squared divided by x to the third, which would be 3 divided by x plus 5 over x to the third. And then here you would say this right here really is just 1, right? That's just 1. So this is 1 right here. On the denominator, you have square root of, and divide everything by x to the 6 right here, square root inside. I will have 4 minus 4 over x to the 6 power. This will go to 0, this will go to 0, and so is this. So I really just have 1 divided by square root of 4, which is 2, so that is 1/2. Now, however, if we were looking at the same problem, but we are looking at limit as x goes to negative infinity, how would that change our problem here? Well, x to the third, when x is a negative number, x to the third is a negative number. Okay, so here, absolute value of x to the third is going to equal to its opposite, because x to the third is a negative number. So when you divide, you really do have x to the third divided by negative x to the third. So that is going to give you negative 1 right there on the numerator, minus 3 over x minus plus 5 over x to the third over square root of 4 minus 4 over x to the 6. So overall, you are going to have on the numerator negative 1, and on the denominator you'll have 2, because these are going to 0. And then so you will have negative 1 over square root of 4, which is negative 1/2. So that's the difference when you are having to divide things out inside the square root. So really pay attention to that when you are dividing by square root of some power. Then you would say square root of x squared. You would think square root of x squared is the absolute value of x, which in turn could be negative or positive. So pay attention to that because it does matter when you do take the the limit as x goes to negative infinity.